Right, so I've ordered a couple of 555s and some new tantalums to replace the tantalums down here. I can reflow around there if I think that's the issue, but well, we'll cover that later. Right now I'm going to get it back in. I'm going to try it without the tape on there, put it back on its original, you know, so that the configuration points tell the board what voltage. And I'm going to measure it because I suspect it's more than the 2 point whatever volts the multimeter was showing. Because the oscilloscope kind of proved that to me, actually. I was expecting 1.6-ish. In fact, I was expecting 2 volts originally. But because I think it was masking 2 pins, that tape, we were down to 1.6 in terms of what it should have been identified as. And I was seeing 1.8. So this makes me think the issue here is about the VRM. The multimeter is showing me an average that doesn't represent what's actually being produced. Right, so that RAM error occurs after, I don't know, 10 or 15 minutes when it's warmed up. I get a lot less shutdowns when the voltage is lowered, but I sort of showed on the scope, I think I showed you on the scope, that I was having like 1.8 volts, even though it should be showing either 2 or 1.6, I'm not sure which. So there's, and I'll show you, where's it gone now? This LV245 here, let's just adjust the line if I can. I think it's an LV245, you can't see it from there. It says there, oh, it's a V125 actually. I think I've got some of those if it's an LV125. But the point is, the configuration pins on the slot for the voltages, I know it's out of focus here, are like these 2 here and these 3 here. And those go to pins up here, pins down here, and where's it gone now? Here, I think. This transistor, which is a bit weird. So those 5 configuration points are getting here. The solder points are alright here. I think there's I measured all these resistors and they're all alright. So it's not like it's misidentifying the voltage unless there is a bit not passing through. The problem is when the CPU's in here, it goes like that. The heatsink and everything's right on the top of this. You can't even probe it or scope it or anything. Nightmare. But I think these down here, I was looking at these going, what are these doing? Why is there a pair of them? This is the PWM stuff. These are used for that. So I could swap these out. I'm looking at this tantalum, and I was looking at tantalums around here thinking, is it going to be a tantalum issue? Something's glitching somewhere, so we don't have a short per se, but I think the voltage is drifting, occasionally having a bit of a spike higher than it should be somewhere. That's what I think is going on, and so I think it's a genuine overheat situation that's going on here, due to slight overvoltage for a period of time. But I can't scope and measure it, I can't see it. When I try, I'll just put it on resistance, when I try measuring, I'll put it on diode test actually. Yeah, so it's like not short here. And of course, it could be one of these passives, you can see, you know, the points don't look great there. Is it one of these that's not making a connection? I could try reflowing around there. What's that, 222, is that 2K2? Yeah, 2K2. 633 ohms, I can't see what that is. It's got something in parallel with it though, hasn't it? What's that thing over there? I don't know. Why's it got little arcs at the top of it? That's a bit weird. Let me just zoom in a little bit further. Yeah, you saw that looks like, hang on, that looks like it says 102 or 201. Should that be? I don't know, it's showing 600 and something ohms though. So, I don't know if we've got a fault there, but what are these on this? This looks strange. I think those are from manufacture. It's like a little mark etched into the top of it. There's one down here and one there. Anyway, this, yeah, it looks alright. They're too regular to be a fault. Yeah, so I guess I'm going to check these transistors maybe as well. And just check everything out around this area. And the thing is, everything looks suspect on this board. You know, the solder points just look a horrible colour. We could have a, you know, a connectivity thing. It might be something that's not connected somewhere here. this is the thing. Things look like they're not joined up and they actually are. Oh. It's now impossible to get the meter at the right angle there, that's joined. I mean, I could get a load of flux around here and just reflow with hot air. I'm inclined to get a replacement 555 or get a pair of them and replace these, to be honest. Again, I can't even get the screwdriver in the right angle here because of the plastic and stuff that's in the way. Yeah, they're all joined up alright. Yeah, those look dark and stuff there, but you've got a dark trace there, look. But again, it's one of those things that I can measure. I can get my probe on there, move the board up this way, and then probe here. So this is the thing, everything's connected. It's not like we don't have a connection. The lighting is a big part of the problem here. You know, it makes it look like you've got some fundamental problem when you actually don't. You know, I can slightly pierce that there. If I can get there you go, so that's connected. You can do the same thing on this one here. Pain in the bum, this board. It's really weird, isn't it, like creating the driver circuit this way with all these components. You look at that one there, that looks awful, doesn't it? It looks terrible, that. Let's just see if I can touch that one, where it's gone, up here, next to this ADV chip, which I think is a voltage type thing, you know, it compares voltages. Maybe this is part of the circuit, actually, now I think about it. But again, it's in circuit. That looks a bit fluffy, doesn't it? Like, is it discoloured? Is it just the lighting? I don't know. It looks charred, doesn't it? Or there's lots of these though that look like that. They're all black and they look like that, and you measure them. It's like 1.2k. So look, there's another one there. .3k. There's one there. Yeah, they just don't look great, even though they are 1.8k. 393, that's comparator, isn't it, I think? You know, again, that just looks terrible. But nothing's loose here. And that's cap, isn't it? Yeah, and I'm getting a reading across it, so it's not like it's not in circuit. Again, I've pressed and inspected all the pins and everything around here, so it's really mysterious. Yeah, and after a bit of probing around, I've confirmed that, I've just put that on the gate, I think, of one of the MOSFETs there for the V-core. It goes, hang on, where is it? I can't remember the name. Oh, it is there. There we go, so one of the MOSFETs is driven by this one. I don't know what that says, DB1, I think that's upside down. Let's just see if we can find another one of those DB1s around here. Right, just trying to find the gate on the other MOSFET, because there's like 2 lots of MOSFETs around there. Is it together as well? Yeah, it does. So both the gates go to the same component. We know that's alright because you know what it's driving at, isn't it? Well, I say it's alright, it's not completely open circuit or failed. It looks alright. So, yeah, you can see the output of this transistor here, sorry, this 555, straight on there. I think there's 2 different things going on here. I think this is V-core, that's what I think. And I think the other 555, wherever that's gone, I don't know where it is, on the other side there. We'll try that as well. Let's just see if that one goes there. Oh, I need to go back over here to this thing, don't I? That's the problem when you're so zoomed in. Let's just go from there, scroll across here. The pin looks a bit dark, doesn't it? Yeah, they both go to the same place. We've got the 3rd pin there, which I think is the output. Oh no, hang on. Oh, it doesn't go there. That's interesting. Oh, that one goes there. What? Yeah, is that to push and pull the signal? Like, so that the MOSFET's working opposite? I don't know. I'm confused by that. What's this? If that is a transistor, how does that make sense? Anyway, we know that pin there goes over here. I need to go look at 555 pin out now. If I measure one of those MOSFETs again, 2.048. See, it's alright now, but that level is going up and down, up and down, up and down. I've been watching this for quite a period of time. There are some big spikes though, you know, like 2.17 volts, etc. And then, you know, it'll drop as low as 1.8-ish. You can see the duty cycle adjusting, you know, just marginally. That's why it sort of wobbles to the sides like that. It's not a regular exact frequency. Anyway, right now it's alright. My arm's getting tired holding it there. 2.05, see 2.13 there. I mean, it would certainly seem that whilst the voltage is fairly stable there, well, we don't get any thermal shutdown, do we? So we need to monitor this now for some time. I could do with soldering a wire on that and just leaving it blooming connected. We all know how easy it is to solder onto MOSFETs on boards. Sets a little on the tab. What's amazing, I've been holding it like this, my arm's getting tired here, holding it for ages and ages and ages, scoping this. And it's not shutting down, it's really hot in here. I mean, it really is hot. I'm burning with this fire next to me. And yeah, we're seeing some spikes like that, 2.11. I've seen 2.18, I've seen 2.2 something. Just a little spike, 2.23 there. See, maybe the motherboard's sensing a thermal shutdown signal when the CPU's not even sending it. That might be an issue. But it's really hot in here, and that's been running all that time without an issue. I've narrowed it down, I've worked it out. Right, I managed to induce a thermal shutdown. I sat here thinking, maybe I should freeze the area of the 555, so I sprayed just down there where the 555s are with that tantalum, and within a split second it's done a thermal shutdown. I'm just going to tell you, hang on, waiting for the error message. I'm guessing it's, yeah, thermal failure. There we go. So that's what it is. It's the VRM for V-core, and it's something around those 555s. So I've ordered 555s, and I've ordered the tantalum that sits in between them too. So I'll wait for the game to load. Right, the game's up. Right, ready for this? I didn't do it this time. It's hard to get that spray in just the right place. I don't know, it's not doing it now. But trust me, it had been on for half an hour and then it just went shh, and it went straight away, thermal shutdown. Right, about a week later, I've got a load of caps. God, I've had a bad week, I tell you. I honestly thought it was a day and I was in A&E the other night. Anyway, that's a story for another time. Yeah, so I've got my components here, got a load of caps. These are the SD bags they always get me. You can't read what things are inside them. It's like you've got to open the blooming things to see what's in it. I really prefer it when they put something on there, you know, and there wasn't anything in that bag that said what these were. Hang on. So, wrist strap is on. Yeah, NE555. Texas Instruments symbol. So we've got our 555 timers. Hopefully they're going to be nothing unusual about the 555s on this, like they're not like higher spec ones that give us higher frequencies. We're dealing with the PWM for the power management stuff, you know, it's in the 100 kilohertz-ish frequencies, you know, and I think most even basic 555 timers will go up to a megahertz or more. So I'm going to remove the two 555s here and the tantalums and swap those things. Is that going to make any difference? I don't think so, but I don't know. So something around here seems more sulky when it's cold than when it's warm, and that kind of fits with the general behaviour that I found, that as this warms up, it works for longer and longer and longer. So like something is out of tolerance or something somewhere when it's cold. That could make you think dry joint, but do you know what? I've inspected around here till the cows come home with a microscope, and I don't see any dry joints anywhere. I mean, having used hot air around this area in a minute, maybe we'll you know, reflow something that was a bad connection anyway as part of replacing these things. I don't know, it's just part of the course. We don't have schematics for it. We don't know really, you know, we don't have any real clues, do we? We don't really have any clues here. Other than the fact that I saw V-core just being a tiny, tiny bit more fluffy than I would expect for any given V-core voltage for any CPU. I think that's the issue. But we could be wrong. We may do all this work and find it's exactly the same. Only time will tell. So let's knock everything on the floor. One of the problems we've got here, if we're using hot air here, we've got this plastic right next to it, and you can't remove this. You can't remove the plastic. That is going to be an absolute mare. So I think what I'll probably do, I was going to say use some low melt solder on that. Yeah, I think I'm going to do that. Just use a bit of low melt solder to remove these things here, because I think using hot air there, it's just asking for trouble, and it's so close to the 555 timer. So I guess it's that place your bets time. Do you think doing this is going to make any difference to anything? I don't think so. I don't know. You know, it could be corroded fire, I don't know. I think what I may do is just reflow some of this stuff around here with a bit of hot air away from the plastic. You can see the plastic here right next to the 555, and if we reflow some of the stuff further away with hot air at the same time after we've finished, then I don't know, maybe it'll work and we won't know what the answer was. Was it the reflowing? Was it the well, what was it? I don't know. Yeah, this low melt solder is really stiff stuff. It breaks when you try and bend it. So I'm going to get some of this down here. This is not going to be easy. Got to use the microscope for this. I tell you what, let's get some flux, because otherwise, well, it's not going to spread, is it? And I'm in such a confined area here as well. You can see, you know, there's little caps and resistors and stuff all around here. One slight movement, and I've got the jitters, means that yeah, you could end up removing something, and that cap's right in the way as well. Removing something you don't want. Right, so that's that. Let's do the same over here. Granted, we haven't got the flux, let's try and spread it. Right, there we go. This is going to be the fun bit. In such a confined area here, I don't really know. I'm going to tempted to push this way, because you know what, I don't want that low melt solder going anywhere near that blooming slot connector. You could argue, let's remove that cap first. So it's a 226, the band is to the left, so let's get that off, because that will just give us a little bit more working space, and we'll replace the cap last. Yeah, fit the new one last. And I'll ESR test these things, obviously, because that might reveal it as well. And I'll do them one at a time, so as we get this off here, oh my god, it ain't so big compared to that gap. Oh. Just rotate that around marginally. Yeah, after we oh, it's going onto there, I don't want it there, that's it. Oh, I don't want to touch that component next to it. Right, what I need now is calf tweezers, and let's just try and get that more central. And I'm going to heat that, get it nice and warm, and there. You see it wobbling already. Get that side nice and hot. Back over to that side, got the tweezers. Try and lift it up. Heat that side. Oh, heat that side. Lift it off. There we go. That was about as good as I could expect, really, for working in such a confined area. You never know. If we're lucky here, the issue may be one of these tantalums. It might be that its its ESR is a bit funny. So I'm going to go right up here and onto that component, just because we've got low melting point solder on this side here, didn't we? So yeah, I'll reflow that. We'll add some fresh solder onto it. Let's just try and get right up to it, like that. There we go. That's looking all right. So the next thing is 555. So I'm going to do exactly the same thing here. Just try and get it more centralised to give myself some space to see what I'm doing. And I need to heat this side. It's not going to take as long this, because you know what, it's not thermally coupled to the board. So we might just, there we go, be able to lift it off like that. God, that was so easy. Low melt solder for the win. I'll probably just do this in 2 phases. I'll replace these 555s and the, oh my god, I can't get onto that, and that one cap, and then just retest it. If I'm not careful here, I'm going to end up removing these blooming things. So I'm going to lift the braid slightly at that point. For good measure, we can just try and reflow those things anyway, because you never know, it could be dry join there. We'll just go down and do that one there. We'll do the same thing. Yeah, I'm just looking down periodically to see where the iron is. We'll do the same thing on these things here, including that pin there. I'm even going to come down here and reflow that via. It is right under that plastic. I may be melting that plastic touching that. I'm also going to reflow some of these things up here, if I can just get a bit of flux over there, like that. Right, that's that. So we just got this one to remove. You can see it's a bit dirty down here, look. It does look not especially clean, doesn't it? So yeah, I think having reflowed this area here, it may help. This may be our issue. See, what we don't have here is an outright failure. So what I mean is, if one of these 555s is the issue, it's not that it doesn't work. If it didn't work at all, it wouldn't be booting whatsoever, and we'd have a voltage problem. It might be popping, for argument's sake, popping CPUs if there was too much voltage. But that VREF thing there, where it is at 339, there must be a voltage reference for it as well somewhere. Some sort of circuit that aids in that shuts the switching down if the frequencies, if the voltage is wrong. See, the thing is, I've never rolled my own PWM circuit like this with 555, so I'm honestly not quite sure how it might work with the components around here. But I would suggest that 339 that's just above, that could be a fault, or something next to it, a passive voltage comparison might be lacking somewhat somewhere. I wonder if schematics for this board actually exist. They must do. Someone must have had schematics back in the day to repair, service these. Like the DELL technicians or whoever it was DELL used to do their repair work, RMAs and things. It looks shockingly bad, doesn't it? It's like, I'm trying to clean this up and it doesn't really look any cleaner. Right, that looks alright. It looks alright, and certainly no worse than it was at the start. We have got some flux just in between a few things though, yeah? The fuse there looks awful, doesn't it? It corroded on top. Yeah, and a few things here, yeah, could benefit from being reflowed yet. Anyway, let's just focus on the job in hand. So, let's get 555 on. So we've got the semicircle there to show pin 1. So let me get one of my new 555s. That'll do. It is slightly more to the right than to the left, and it's going to move. It's guaranteed to move now when I touch some solder there. So just clean the tip thoroughly. I need to come in, get onto a pad. I just had some solder and flux. Let's just try get one pin to bite like that, and then I can just try and use the tweezers, I think. Yeah. I still don't feel that's right. I can't see it now. Where's it gone? I need to just press it down that way slightly, and then up this way slightly. The best way to do this, if you ask me, see, I need this side to go up a little bit. So what it's best to do is to anchor it here. Hang on, try and anchor it here, like that, and then this is really hard to get the thing right. I'm going to pull it by this pin up here. Hang on. So I hit that one pin, if I can. See me just pull it upwards slightly, and then release the tension on this pin. Now that's pretty much perfect, even though if you took this off, one of these pins would have a tiny, tiny, like 0 point something degree twist in it, if that makes sense. It's just a nice way to get it nice and straight and central and stuff, without risking, you know, making a mess of it. That's the bottom line. I'm very nervous about working in this area, really. You know, like, these components, are they any good, these 555s? Are they clones? Are they fakes? Are they crap? Because this is where you really want this circuit to be perfect, or you risk killing processors. And again, a mistake in this area, you could kill a processor if you bridge something somewhere and this 555 PWM circuit doesn't work properly. It could be bye-bye CPU. Now, I've got a bunch of Pentiums here, some of which need repairs. Yeah, you may think, repairs? How can you repair a processor? Well, we'll see in the upcoming video. But I don't want to kill Pentium 3s. Yeah, so I think in general that looks okay. Looks like we've got reasonable solder. I don't see a bridge. But I think we'll test as well on continuity just to make sure we don't have any shorts there. We'll toothbrush this in a minute when we've got the other 555 and that tantalum on. Right, that's that. Let's just clean this area here ready for the other 555. I don't like the amount of solder there, but you know, beggars can't be choosers. I'm just going to go with things, I think, as it stands at the moment. never going to be a Picasso, this. So I now need a 226 cap. Yeah, so 226 is 22 microfarad, and they were 25 volts, I believe, the ones that were on there. So is this going to fit? Hopefully it will. It's going to go like that there. It's a bit bigger than the other one, that. You know, in its height, I mean. But it is the right size, look, so you know what, I'm happy with that. Oh my god, that's not gonna, oh yeah, say join. Oh, flip. Yeah, I'm gonna try and get it straight. That'll do. He might not be as straight as it originally once was, but well, it's the best I can do with the restrictions I have here. That tantalum's massive compared to the previous one. In height, I mean, it's the exact same pad spacing, but it is a lot higher. Yeah, it's twice as high as that other one. Got no chance of cleaning anything around there this way. I can do what I did before, mask off. I'll get a slightly larger mask this time, so, you know, pinch some paper towel. Got to try and visualise in my mind's eye how big the area was, so it's about yay big. So just rip that out. Get that over that whole area there, press it down like that. And then, yeah, cap of IPA, toothbrush, and you just look close at what you're doing, really. I'll report back in a minute. It's been a while since we've been on Super Macro, but you can see that area. Yeah, the light's not great in here, but that looks alright, doesn't it? Got our two new 555s, reflowed things all around there, and we've got our new tantalum. So let's get it back in the case and give it a try. Right, so I've got the board back in. I mean, this heatsink is still not great on this here, you know, it has suffered a bit of damage there. That's not the problem though, because we tried it with different clock speeds, different processors. The same problem occurs on all of them, so let's now carefully push the processor back in. So, the key now, what happens when we power it on? Got a display. The main thing is it's powering up, isn't it? Right, while that's going, I'm just going to get the multimeter out. I'm going to measure the V-core, we'll scope it as well. Yeah, we're still seeing some variation, but you know what? I think that looks cleaner than it did before. 2.07, 2.06. So it should be around 2.05, so we do still have a tiny, tiny bit of variation. Maybe I need to swap all 4 MOSFETs, this is the thing. 2.23 I saw there then. So this is the thing, I'm calling it now and saying that's probably made no difference whatsoever. I think we'll get a thermal shutdown at some point here. But you see, unless you're scoping over a period of time there, and then look at what you had on the scope versus the thermal event, you don't know. For all we know, there was a split second in time previously where it was going above, like quite a lot above the level, and that's where you get a thermal shutdown. For argument's sake, say it went to 2.3 volts or 2.4 volts, in a very short period of time you'd get a thermal shutdown. So there could be a problem around there. We may have fixed it. There could still be a problem around that circuit. I really despise this Pentium III. I hate it. I hate it so much. It's done 3 thermal shutdowns, well 2 thermal shutdowns actually. It lasted for several minutes to start when we first tried it, and then it thermal shut down. I powered it back on, lasted 2 minutes, and then it thermal shut down. I switched it back on, went in the other room. I've been sorting out the SD card because it filled up with footage, and I've been in there 15 minutes or so. This has been running 15 minutes now. And this is the thing, there's no rhyme or reason, is there? It's now lasting longer than it did the previous 2 times. Yeah? Maybe it gets, I still have this theory, maybe it gets better as it warms up. That could indicate a dry joint somewhere, maybe on the board, maybe that's the issue. But, you know, I've just been talking to the guys in Discord, and they've suggested some nice things, which stuff I've already done, like looking the BIOS or any settings. Try and load a thermal monitor of some sort. Well, we can't generally, because I mean, I could, in theory, if this warms up long enough, maybe it would remain powered up long enough to install Windows. I tried that before though, and a few times it just kept cutting me off. You know, I'd get halfway through the install because it just take a while, and then power would go off, and I'd be like, oh god, I've got to format and start again. I can't find any DOS utilities to show me the CPU, and looking around the chips on the board, I can't see anything that's clearly got a temperature sensor built into it. I mean, I haven't looked at the PCI chip from Intel there. Maybe that has something in it. But I mean, even if it does, I can't do anything about it. It's a BGA mounted chip. In theory, I could try and replace it if I can find a donor. Well, I was looking on eBay for about, I don't know, 40 quid-ish. I could just buy any board. There's something, not a new board, but an old stock board. There's a seller of a number of these boards on eBay. I might just swap the main board, but we'll have that as the absolute fallback at the end here. For now, I've not given up. We've got 2 or 3 more tantalums to replace further into the board that I don't think they've got any relevance to anything here, but, well, I don't know. The 555's had nothing to do with it, and that tantalum either. So, But we did see on the microscope, and it is a bit fluffy around that area, so you know what, I think the next thing, I'll wait for this to thermal shut down again, I think, and then I'll take the board back out, and I'll reflow with some flux around everything around there, including the wires, because there was a time like this where it warmed up, and then I got the cooling spray, and I sprayed down here like this, and it went off. So you know it's not doing. So was that? It must have been a coincidence when I did it last time. Nope. I don't know. Hate it. Hate your Pentium 3. I mean, one other thing I keep coming back to is the power supply. You know, not just V-Core, but like the power supply in general. I'm thinking maybe, and I've measured the voltages and scoped the voltages. They look all right, but maybe over a period of time the power supply glitches out. Maybe the 12-volt rail just spikes by half a volt or a volt or something, which messes up the PWM. Yeah, just checking all the voltages yet again. You know, this is the 12-volt rail, just on one of the connectors here. It's not an ideal place to measure it really, but 11.88, 11.89, it sort of hovers around a little bit. I'm thinking maybe the 12 volts is an issue. And we ruled out the drive and the 12 volts to a degree by testing it with a compact flash as well, you know, instead of the spinning metal rust here, and it was no more stable. So it's not like the hard drive is introducing some issue on one of the power rails, either 5 volt or 12. So it got a bit higher there, 9 something. Now I'm assuming the 12 volts might be what's used to generate V-Core, but it might not be. It might be coming from the 3.3. There's like a separate connector for 3.3, but I measured that a minute ago and it's very, very stable with 3.3. Right, for the first time on this series here, I was ranting in my Discord about this. I haven't really shared much info about this until now. And I think Gravitone was helping me out, and 1 or 2 other people. Eric was as well. Maybe Brewin. I'll put the names top left just because I can't remember just now. I've got a massive headache. Anyway, I've got a compact flash card in there. One of the guys provided me with the diagnostics image. Now, I already had that, but the problem I've got with the one I've got, it needs Windows. It says this will not run to DOS. You know, I'm like, oh my god, great. I need to somehow get Windows onto this when it's flaky as anything and powers itself off. Try and install Windows or something like that. I mean, granted, when this warms up, as it had done prior to me doing this bit now, it'd been on for half an hour and it hadn't powered off. I could have actually installed Windows at that point, but, well, I'm just going to corrupt my drives, aren't I, if it does go wrong. There we go, that's in. So, I've copied the files, and the way I did that, I used DOSBox, mounted the image using image mount, yeah, in DOSBox, because it's a .img file, and I could see it as the A drive, and then I mounted a virtual folder on my Windows 10 PC, I think it was on my E drive somewhere, to a fake D, and I just copied from A to a folder in D, and hopefully this will work. Switch it on. So I put in from the compact flash card, and then obviously I copied those things to the compact flash card. Of course I do now need the keyboard again, so nothing about this has been easy. See, if you set up to work on lots of these old PCs, you'll have all the things you need, like, you know, I don't know, an old machine, and I have got one, the DELL 2, you see, the P2. Let's just do F1. LAN works, what is that? Have I just chose boot from LAN or something? 3com? Where's that come from? Now it's got power. Yeah, my compact flash adapter was lacking the 5V connection. So we'll try that again. Well, let's just do that anyway. I think we need some memory from... When I tried it in DOSBox, it ran the utility in DOS, but it said you need high mem. So let's just see what happens with this. Got to try and find what drive it's on there, because the drive mappings are not the same as when it's in Windows 10. Oh, it's there, DELL. So it's on the E, DELL. I think I called it diag or something. Yeah, diag. What's it called? Looks like it's a bootable disk, look. DELL diag. DELL diag. Processor is in protected mode, code and diagnostics. Oh, joy. It's got its own auto-exec.bat, hasn't it? I want to just see what it's doing. Oh, it's just running it like that. Well, it doesn't have high mem. Let's have a look at its config.sys. It doesn't have one. Well, why didn't it run on the other machine? Because there was no high mem. So, I mean, what I can do here is just Control-Alt-Delete it. Press F5. Hang on. Which is an interesting thing on this Microsoft keyboard, because as default it disables the function keys. Right, that's it. Disable the auto-exec and config.sys. Let's go to E, DELL. Oh, I'm too fast here. Diag. I'm going to go auto-exec with a C. Oh, I haven't got DOS key loaded. Oh wow, that actually works. It doesn't say up there S500 plus diagnostics. No, I don't want to do that. Oh, I can't quit out of it. Because even though this is working, the little thing there's spinning around, a comprehensive memory test, I know it's not the RAM, it's just a pointless flipping thing, so you know what, let's power cycle it and do the same thing, go back round again. Right, so we're back in there again, let's do specific tests. It doesn't show what they are, it's like one selected, one. Doesn't show anything there, does it? Temperature probe handle, no probe provided, so there isn't a separate probe. Max hang on. Current fan speed not applicable. Max man non-critical threshold not applicable. Max min critical threshold not applicable. Oh joy. Present status critical. Current temperature 127 degrees C. Reference reading 0. Well, we've learned something here. Environment information SM BIOS. SM028 fail. Device state out of acceptable range. So now I've got something here, if this is right. I don't know, I'm going to take a screenshot of that. But like, what does that mean? You see, the fact we've got 127 degrees C there shows me that there is some issue reading something somewhere, and it's saying present state is critical. Temperature probe, but it said there was no temperature probe connected. And there isn't a temperature probe, there's nowhere to connect one. So, that might be crap, actually. I don't believe that, because if we do that again, right, let's just do it again, and we'll go around here, and we look for the temperature bit. You see here, temperature probe handle, no probe provided. There isn't one, this board doesn't have one. But it does say temperature probe handle, no probe provided. And then this is the temperature probe bit. So, and I'm not sure what this is here. Environmental information, SM BIOS, or system management BIOS maybe, SM028 fail. Again, What does that mean? Where is that? What does it mean? I don't know. But if it was critical, it'd be shutting down, so it's not that. I just think that relates to a sensor that isn't there. So we've not learned anything, really. You can't see the CPU the temperature here. System set. Can run some of these other tests, I guess, see if there's any clues from something else not being quite right. Because it did cross my mind if you had a clock issue somewhere, like interrupts controller test peak, fail, no interrupt detected for IQ6 disk controller. I mean, that might be legit, because you know there's no floppy drive connected at the moment, and it may even be it's switched on in the BIOS. I can try and connect a drive up and see if that goes away, but anyway, it's not revealed anything, has it? I mean, one interesting thing here is, going back round to this again here, it says here, test status cooling device. So this must be looking at the fan. Yeah, now I already showed you, there's something on there that looks like it could be a temperature sensing device. But it's saying, hang on, yeah, the device number, type, fan, temperature probe handle, no probe provided. So maybe it can't, and there isn't a pin for it, but you've just got three. You've got ground, 12 volts, and then the sense pin, which is the RPM. But maybe it's not the RPM, and maybe it is that little thermal thing that's on it. But then it says here, present status safe. So the cooling device is alright. Yeah, and then the temperature probe is something different. And this is where it's saying critical. You see this 127 here, I think this is a default, because you know what, you can't read something, something's not there, it isn't fitted, there isn't one. I can't see that being the issue, because you know what, if that was the issue, would it have not shut down by now? If it's critical, would that not have shut down? So I actually think that only relates to some of the models where you have a temperature probe, because some of them do have something you connect to the board somewhere and it goes out to the case somewhere. This doesn't have that, and there's no connectors to fit something like that. I've thoroughly inspected around this. So I don't think that's the issue at all, and I don't think this really has revealed anything. So annoying. So I'm not getting anywhere here. I'm just going to power that off. Long shot, what I'm going to do, I'm going to remove the CMOS battery here. Oh God, Bennett! It's like even changing the batteries in it there. Well, pull that out completely. I'm sure that battery was replaced by me. Anyway, I'm just going to leave the battery out. I'm going to try and let the CMOS settings go completely flat. One way to expedite the process is to literally make sure your power's off. Short out your contacts here. Yeah, I was looking at that fan and the connections on the board. It looks like there's an optional transistor for the... See this thing, that didn't reset the BIOS, did it? There's not even a battery in it now and it's still all the sense. Cover was previously removed. Yeah, we didn't get that before, so you know what, maybe that has worked. Well, I'm just wondering if there's something configuration... Yeah, there we go. If there's something crazy in the BIOS here. I don't know what that would be. Hang on. I'll just leave that running around. Bear in mind, it's not got a battery, but what might have happened is the CMOS settings might have got reinitialised. There's not even a way to default them to factory settings, is there? If we get a thermal shutdown again, at least we kind of know. It's probably nothing to do with some rogue BIOS setting. It'd be annoying if it is that. That's how much spin on it. Nope, a minute and a half later, thermal shutdown again. So anyway, I'm just going to clean up that battery. And measured it, it's 2.9 something volts. It's not quite brand new, but I did replace that, I don't know, about 3 years ago, when this first arrived here and I did some quick tests. The earlier part of the video really, so anyway, battery's in. Switch it on, and we should see previous thermal failure. Oh joy. You know what, I'm tempted to go and look for a replacement power supply actually. Just because if I got one of these and just swapped it out and the problem went away, then it would be worth the time. So let's get that there, and it slides like that. Rotate around. Consequence of a wrist strap is your wrist strap cats in everything. Let's get that one screw back in here. Yeah, I was surprised that there are no other power supplies online for this. You've got sellers on eBay selling the motherboard. What did they do with the power supplies? I'm guessing they scrapped the wire for scrap value and then thought, well, the motherboard might be worth more than the bit of gold you could reclaim from a board like this. Just thought I'd show you this diagnostic stuff is inconclusive. If I run through the tests here, I switched it on first thing this morning, I've been using it for 10 minutes and everything works, and then rebooted it, got into the diagnostics again. If we go through here in the system management BIOS stuff, that's the first page regards sensors, and it just says, you know, there's a fan, no probe provided, safe, everything's good there. And then you go to the next page, and then we've got CPU internal temperature, safe. Now, this appeared yesterday a few times like this, and then I readed the test, and then it would come up, and it wouldn't say CPU temperature, it would be a load of failed things with 127 degrees detected. I mean, it's saying current temperature 0 degrees, reference 0 degrees, so it's not actually working because it's not detecting any temperature there, is it? But the point is, you can just go through here and then control break it, go back round again, and I managed to do this several times now and it's been alright. And then you get critical. We haven't got that now. Yesterday it did it the second time round. It was right the first time round, I went and tested again, and then it got a critical. So, like, is it, I don't know, something intermittent on this board? I think it is. I think this is the nature of the problem. We have an intermittent fault. Looks alright now. Oh god, it's driving me nuts, this. There you go, critical. See that? And all we've done is just go in and out a few times. So it wasn't critical a minute ago, and now it's saying the reference reading is 77 degrees, and it's saying the current temperature is 127 degrees. I just can't make any sense of this. It's bizarre. It's like, why was it alright, and then it's gone off, look, there we go. So clearly, something is going on. Reading the CPU temperature. Right, after an absolute ton of probing around on here, using the microscope here from Kavanos, couldn't have done this without this microscope, incredible. Kavanos to send this to me. If I probe on one of the thermo pins that come from the CPU slot here, finally found a connection here. But you know what, a few things look fluffy around here. I'm going to get some flux around, tin around, inspect some of these fires and traces here. But anyway, it's that third pin there. This chip, I can't find anything on it. I think that's the analog device symbol. It's 51039. So it goes here. But yeah, the solder points look crusty around here, so you know what, I'm going to reflow this whole area. Maybe it is just something around there. I'm very pleased though, because I've worked it out, and I've been trying to work that out for some time now, you know, trying to understand where the thermocouple signals go. So I mean, following that trace, is it one of these ones? I don't know. It's like, this is going to take some time to follow. I can't even see where I am on the board now. Here, it's this like third pin, isn't it? So yeah, I'll use super magnification in a minute. I can't see, does it go there to this point, or does it there? I don't know. It's one of these two, and then there's those two traces come all the way down here. It's not those ones, it's something that goes to the left there, looking at those. But yeah, it doesn't look so good there. Let's just zoom in super close and we'll have a look at that chip as well. Maybe it's just a bad solder point on that chip. I mean, that would be just amazing, wouldn't it? So let's just have a look at that chip in particular, if I can find where I am. The tool is huge now. Let's just press these. It'd be really amazing, wouldn't it, if one of these moved? But, well, I don't think so, because I'm sure I've looked all around this area already. But look, I mean, the solder points don't look hot at all. And yeah, there's, you know, some discoloration there, but I'm just not even pressing here, I'm just literally touching the surface. I mean, that looks fluffy, doesn't it? It really does. You know, some of these capacitors, yeah, the solder points don't look great. And if I press on any of these things, everything's solid here. So, I don't know. It might be this chip. And you've got to look at, you know, the things that that chip uses, like these connections. I mean, again, that looks absolutely crusty as anything, that. And that. Everything's solid around there. Yeah, that's the PLL chip. We're going a bit too far up there. When I say PLL chip, I mean the RAM buffer. Yeah, I think I'm just going to reflow some of this stuff, to be honest, because there are no other clues here. I don't see any faults. Guess what else I should do? I should just check the other pin, because there's 2 pins for the thermo stuff. Yeah, 14 and 15. I think it's like B14 and B15. So this is the other one. Let's see if this has got any connection here. Yeah, it's those 2 pins. Those, 14 and 15, go to those. If I move to the other one, hang on a sec. If I can find the flipping thing. Yeah, there we go. So, yeah. How would that be a fault, though? How would there be a fault? Unless this chip was bad. We've definitely not got a connectivity problem, though. Right, looks like we didn't do much there, doesn't it? But you know what we did? We did reflow, you know, heat a number of things where solder will have melted. I mean, namely that, but you could see I could move a few of these things, despite the fact they don't look very clean. We'll see if that's made any difference whatsoever. Again, we could be barking up the wrong tree, because it might not be this that's the problem. It might not be the temperature sensing from this that's the issue. It might be wherever this goes to something else. Yeah, so it's a rabbit hole, this one. It really is. We don't really have any clues as to what the actual fault is. All we know is getting a thermal shutdown, and it could be goodness knows how many different possibilities, really. Yeah, anyway, looking around that then, so do we see any NTC, PTC things? Because it could be doing 2 things though. Might be looking at the motherboard temperature and looking at the local temperature, but you know what? I see some capacitors, I see some 0 ohm links, a resistor. I can check these resistors here. I'm sure I've measured these already, these ones, I remember doing it. What's the little blue thing there? Is that another 0 ohm link, or is it? Don't know, let's measure it. Maybe that's an NTC, PTC. Wouldn't it be funny? I don't think it is. I think that's probably a 0 ohm link. No, it's not. I mean, it's marked R something, isn't it? Capacity below it, a load of more resistors, caps, that little black thing down there, that's a resistor. There's millions of those on this board. So it's not like that's a mysterious NTC or PTC. Yeah, it's like 680 ohms though. That's got me interested though, just because it's next to this. Let's just see, does that go anywhere? No, I mean, see, this is the thing. This could be part of a different circuit here. It might not go to this thing. You see, if it were something like this, you'd think it'd be temperature sensitive as well, and it isn't. It's telling us it's temperature sensitive, but it isn't. Yeah, so I don't even think that is part of the circuit. It's for something else over there. I don't honestly think that's an NTC or a PTC. Let's just measure its resistance and see what it actually reports. 1500 ohms. I actually think that's just a resistor. And it does say here R15 something. It's annoying, isn't it, when there's no consistency in the components on the board like this. There's so many different styles and different manufactured parts, you know. They used a real oddball mix of components. And the thing is with this, if this was an earlier board, you know, like, I don't know, a 486 or 386 or something else, anything other than the slot 1, you'd be like, I know, next thing we'll do, we'll scope the connections around here. Try and do that when the heat sink comes like this here, yeah? The whole CPU, yeah? You can't. It's absolutely impossible. These must have been an absolute nightmare for the industry back in the day. It's like, I don't know what Intel were thinking about with these slot CPUs. It is why it never got continued. Surprise, surprise, it was dropped by the time we, you know, finished the Pentium III. And they quickly moved on to the separate chips, didn't they? And yeah, I remember my Celeron had an adapter for slot 1. It was an actual, you know, normal pin type chip with, and you used an adapter that went into the slot. And what's a shame with things like this is because systems like this really got moved past very quickly. You know, superseded with Pentium 4 and all the million things that followed it. No one cares about it. No one cares about this. They don't care about the board, they don't care about the processor in general, you know, this revision machine, etc. Which means there are no postings on it. You can search online, you'll find nobody. You'll find someone else like me who's got a thermal shutdown thing, and you'll get a reply from Dell going, clean out your fan. That's it. That's it. You don't get anything else. There's no service logs, there's no schematics, no one's even interested in publishing or servicing these things moving forward. So you can argue things like this really are lost to time, not like the other things we cover on my channel. Those have a lot of interest in them. This board will never have any interest in it beyond me looking at it. Yeah, maybe one or two of the people in the history of humanity moving forward may gain something from this video. So there's a thought for you about, you know, is this really a desirable machine? Well, the architecture is. The machine, nothing special about it at all. It's one of 10,000 Pentium III machines that came out at the time, of which 99.9% have gone to landfill. That is not the case with the Commodore 64, with the Amiga, with, you know, the earlier PCs, IBM PCs, for example. Switch it on. It's booting up. Previous thermal failure. Interesting with that, that's the best that's ever fit on that screen from the start. It doesn't usually fit on that well. So, I don't know, run it for a bit, see what happens. I mean, what I should do really is quit out of this. Just quit out. And just go into the diagnostic. Oh, it's shut down already, look at that. This is the thing, this is what happens when it's really cold. You get a thermal shutdown, often, within a minute, look at the previous thermal, within a minute of it coming on. Oh, God, but it's worse now, look. It's doing a thermal shutdown within a minute of being on. Oh my God. Well, there we go. It's far worse now. It doesn't even stay on long enough to do anything now. Oh, what have I done? All I've done is heat it. And it's well cool now, it's not like it's overheating here. See if I can get in here before it shuts down. Hang on. A sec. I'm not going to have long enough to do a diagnostic, am I? Oh, you! Well, there we go. I think we know what the fault is. I think we've worked it out. How do we fix it? I'm not bleeding sure. I think what I should do is just measure all the resistors and caps around that circuit, because we might be lucky, maybe one of them has just got a bit worse from being reflowed. In other words, one of those resistors may now be not measuring what it was before. Well, there you go, we've made some progress. It's not the progress I wanted, because now the machine is completely unusable. You can't do anything in the 60 seconds, can you? If you look at the size of the 060, hang on, 0603, the second one down there, and then compare to the size of some of those things. So at this point here, I checked around all those resistors and caps around that little ADV chip and cleaned up the area with the toothbrush and stuff, and just made sure everything was alright there. I did find some 8K2 resistors that didn't quite measure 8K2, they were like 8.07 or 8.09, so I thought, well, maybe it's got precision components around it, so I did order some precision 8K2s. Hunting for information on that chip revealed nothing. I couldn't even find a description of what the chip is. It's not on the Analog Devices website, it's just nowhere. I couldn't find any online for sale anywhere, apart from finally I checked AliExpress and there was one seller who had a small batch of them, and I bought 5 of them for a total of £1.76. They were like 30-something pence each or something. Right, so here we are a few weeks later, back on the bench. I got some low melt solder. I'm going to remove it with low melt solder. Got in a non-safe ESD bag 5, I think. Yeah, 5 replacement chips. Now I haven't tested it today to see is it doing the same thing where it powers on for like 30 seconds and then powers off. But anyway, let's swap this chip. And then, do you know what? I've kind of got low confidence that this is, hang on, I've got solder everywhere here, that this is going to fix the problem. I'm not 100% sure it is this chip, but, well, that's the thing with reflowed and the stuff around it. It could still be one of these, that blue component down there. Like, is that a PTC or NTC? Well, it'll be a PTC. It can't be a negative temperature coefficient device, really, if you think about it. You want to measure the temperature increasing, you know, not decreasing. I think. I could be wrong with that assumption. I think that's the way that's going to work. But anyway, yeah, is it this chip? Is it not this chip? I don't know. Anyway, I'm just going to rotate this around so I don't melt the plastic nearby the standoff for the slot. Yeah, but low melt solder, I think, is the best approach here. And then go over that side. There we go, it's coming off, look up. Wait, it was coming off, and now it's sticking. That's what I was worried about. I was worried about it sort of getting squished around. I don't think we touched anything around the outsides there, that looks alright. They're reclaimed, yeah, like a lot of stuff on AliExpress from this generation, you know, the chips from this generation. They are reclaimed off boards, so somebody has scrapped, presumably, some DELL boards with these on in China. They may have actually been scrapped in India, I don't know, and then the parts work their way to China or something like that. And if you've seen any videos on those, what they do is they get like a cement mixer, you know, think of a cement mixer, you know, a metal cylinder that just goes round like that. Yeah, they put the boards in it, but they like furnace the cement mixer. It's like it's got a furnace there, getting it up to like 400 degrees. And it rotates around with board parts and things in it, parts of PCBs, and they all just fall over and tumble, and eventually the solder all melts and all the chips all come off, and you've got this pile of chips with mangled legs, you know, and those get collected, and anywhere the legs can be tidied up, they get sold on. So that's probably the origin of the 5 chips I have here, unless someone actually took the time to, before doing that approach, to remove what they think might be useful and may sell on those boards, and these chips may have come off it just with hot air, so they might not have been totally baked and what have you. You can see the pin one here, look, the little silkscreen, so we're going to have no problems getting a new chip on. Yeah, so I've got a 60% confidence in this fixing it, and if it doesn't, I've then got maybe 100% confidence that something around there will fix it, like a hang on, let's put those away, like a resistor, or that blue thing which may be a PTST thing. Let's try and get that down. That's upside down, it would be. Law of averages, is it 50% chance it could be the wrong way up? Well, it's always the wrong way up, so it's, I call it 100% chance. There's no probability in flipping chips and components. It's like 100% chance it'll be upside down for me. I mean, you may not find that, but I do. If it can be the wrong way, it will be. Right now there's no solder. Now there's no solder on it, I think. As I lean slightly to the right here, the iron, such as a heatsink that's nearby, you know, there's just literally no clearance. That side kind of looks alright. So I just need to just get like that, I think. You can still see the blob. Oh, still a bit there. Right, now we've perhaps got not enough solder. Let's have a look to see if these are going to flow. Do you know, from this distance, I've got very, very bad visibility even with the magnification. The pins don't look great on that, do they? I don't know. I think that's it. I think that's on. Haven't got keyboards connected. Right, let's power it on to see what happens. We've got video. I don't know. I don't say anything. I've got the suspicion it's going to switch off very soon. What we do know though is that chip goes to the thermo connections on the socket one. So if it wasn't going to be a chip, it would be that one. It is a question of how did it die? That's what I don't get. Was this machine run for God knows how long overheating and eventually that chip died? Or was that chip subject to failure? You know, I don't know. Anyway, I'll report back, hopefully with good news, not bad news. So, I'm fully expecting it to turn off any minute, but it's been going several minutes and it's still on. So, the time there, 13:10. I'm just going to leave it running for a bit and a few hours, I don't know. Come back at 3:10 or something and see if it's still working. If it is, that would give me confidence it's okay. 2:15. And it still hasn't powered off, which is a miracle. Yeah, I'm holding my breath still. Let's give it until 3:15. Well, it's either extremely fluky or we fixed it. 15:10, and it's on. It's been fine 2 hours. That's pretty good. That's the best that's ever been. I've never had 2 hours out of it. So I switch it off. We'll power it straight back on again. Because this would often be a thing. Sometimes you might get a minute or two and you switch it off, switch it back on, then you get, I don't know, 30 seconds. That's keyboard failure. Ignore that. So I think that may have done it. I honestly think it's fixed. Yeah, I'll leave it for another 20 or 30 minutes, just make sure it doesn't power off. But if it survives, you know, next time I come and check it, I'm going to assume that that's now fixed, so I can finish cleaning up the case and get it all back together. Right, so that flashed there following the reboot. I'm assuming it will seek here first. We should hear it making noise maybe. Yay! Brilliant, absolutely brilliant. That machine has been a long time in the coming in terms of the repair. You know, it's like started at I think 2018 or 2019, and here we are 2025, finally finished it. That's what determination does when you don't give up. You will always get there one way or another. I mean, the worst case is I could have swapped out the motherboard, but you know what, I'd rather do a component level repair, and we've done that. And I guess it's had new PWM circuit and new caps on the way. So I've cleaned up the pins on the old chip there. These ones need to come out of that bag though, because, well, it's not an ESD safe bag. And get them into this one. So those are always useful for future, and to fix another one of these perhaps. Don't know how common that fault is, obviously. We'll have a look at this one under the microscope next. There we go, that's maximum zoom. The obvious thought is if I was to measure this chip and compare to, hang on, let's try and get the focus right. If I was to measure this chip and compare to one of the working ones, might be able to, on resistance mode, determine which pins are faulty here. I mean, it's interesting that if you look at the top of it, it's discoloured. Was that from the original reflow with hot air? I don't know. But the ink has come away there, and at the bottom here, there's a bit of what looks like fluff or something there. Let's just see if I can get that off. But one thing I did notice when I was looking at this before, under magnification like this, super magnification, is if I rotate this here, just look at this corner pin up here. Hang on, I'm not sure it's going to show. Yeah, it looks like a bit of corrosion, maybe up here. Like a bit of corrosion. As if maybe corrosion has got into the chip, I don't know. And looking at it on the underside, I'm sorry, it's really wobbly. Yeah, they look a bit corroded and a bit oxidised, don't they? It's hard to clean the underside like that, even with a toothbrush. That looks pretty fuzzy, as if like oxidisation, look. Unless that's just flux, I think that's a bit of corrosion, you know. I think corrosion has got into that. So I plugged some speakers in and set the sound card setup to Sound Blaster 22515, and it works. It's like I haven't even had to install any drivers or anything. Let's see if there's any music. Yeah, there is. Wow. It doesn't even need a sound card. It's incredible. Using keyboard, obviously. Sweet. Doesn't it run really well on a P3, this? What's amazing with this is the settings, 225.15, you know, 220 base address, IRQ 5, DMA 1, high DMA 5, I think, and it just works. Often you find the parallel port would clash, and often you find the sound cards 240, you know, base address 240 is the default with an IRQ of 7, which then causes problems with your parallel port, unless your parallel port's on a different IRQ. But, well, this just seems solid on those settings. I don't know how you get up there now. That bit comes down on its own, I think, maybe when you go through here. It's quite hard without a mouse. And of course it's got a mouse port. Yeah, I could plug something into that. See if that thing's gone down. Yeah, it has. Because I think there's a shotgun there, isn't there? Yeah. Oh, yes. I always thought there was a way to get up the top where that imp comes from. I think there is. I don't know how you get up there, though. There's a secret here. I think the way you get up there where that imp was is, and I could be wrong, you've got to run through this section here. There's like a trip somewhere on one of these lights. It might be this one. I don't know, I'm just trying to remember. Right, look in the corner. Hey, well remembered. I still don't think that's all the secrets on this. Let's just complete this level, see if we've got 100% secrets. There might be another one. Hey, 100% secrets. Fantastic. Oh yes. Right, I'm going to save that actually. Might have another play on it later. Let's just have a look how much memory this has got. I can't remember now, is it 16 meg? 64, isn't it? In fact, it might be 128 meg now I think about it. Yeah, I think it's got 128 meg module, but 64 of it is shown up in this configuration here. Yeah, install. You have extended memory available. That could be configured as EMS. Too little memory to run X1 with sound, oh joy. Yeah, so we can do device equals C colon DOS EMM 386.xc. I think you put the size after that you want, so I mean I could do, I don't know, 4096, that should be 4 meg, I think. I could be wrong, I honestly can't remember what the switches are for that. Let's try that. X1 install. That's better. Soundboard, not bard. Sound blaster. Configuration. Did I just do that? Sound blaster. Machine speed. Let's choose yes. Heart fast. Exit. Yeah, unless you've got the set blaster things, it's not going to work, is it? Which we haven't, so I think we won't get sound. Oh, we do. Oh, that's strange. Maybe I did have the blaster statement set or something. Wow. So many fun memories of playing this game. I played the heck out of it. Look at the speech.
Sir, our TIE interceptors have located a rebel fleet orbiting the planet Orkana.
Excellent. Prepare the attack. Move our Star Destroyers within range and launch all TIE fighter squadrons.
At once, sir.
We are under attack by Imperial Star Destroyers. Begin evasive maneuvers. Launch the X-Wing fighters.
This is Red Leader. Stay close and watch for enemy fighters.
Got him. Follow me. I can't take him.
I'm on him.
Nice shot, Red 2.
Fantastic.
Welcome to the flagship Independence.
One thing I'm curious about here, it's been obviously running for a few hours, I've got a wrist strap on, just got to touch the case just to ground myself as well, and I'm just going to finger touch that little chip. It's stone cold. And there's good air circulation there, I feel cool air from that fan and from the power supply as well. So, I don't know why that chip died, no idea, must have been corrosion. Yeah, and running check it here from the floppy drive, video memory test. You can hear the drive. Yeah, the floppy drive's working fine. This only tests up to 16 meg, but just watch how quick this passes. Look, a full 16 meg. It took about 2.5 seconds. Test memory on a 286 or an XT, and you'll wait quite some time. Watch that again. About 3 seconds to test the base memory and 16 meg. That's incredible. Wow, that works. This might be one of those games that uses or needs AT slow, I don't know. It's a Dungeons and Dragons based game, this, I think. Yeah, it is. Official D&D. And I did get some precision resistors here. What you can see, they were 8K2, 1%, 0805s. They look exactly the right size, but we didn't need them. That would have been the next course of action, really, other than that little blue device, you know, that looked like a resistor. It probably is a resistor, but anyway, we still don't know what that was. That's the problem when you don't have schematics. I could take it off and measure it, and that'd prove what it is, really. I did experiment heating it and measuring its resistance, and it didn't change, so I don't think it's a PTC. We've got so many 1 and 4148s now, everyone just gives them away for free. Alright, so I'm going to wrap things up at this point in the video, I think. We'll get the lid back on. I taped the couple of pieces of white plastic here that I cannot see where on earth they've come from. I'm going to just stick those on the inside here, on top of the floppy drive. Like that. I don't know where they're from. I've looked absolutely everywhere. You know, I can show you here. It's like the obvious places, like these types of clips and things. But inspecting all around this, I can't see a single piece of plastic chips off anywhere on any of the fitments around the edges, or I just don't see anything. So I don't know where they came from. To get it back on, there's 3 gaps in the front of the case. One on the left you can't quite see, and they correspond with these things here. You know, you just sort of just looking at those, yeah, they're all alright. None of them are broken off, so I don't really understand. Yeah, so put them into the gaps and like that, and then just hinge it like that. Yeah, you can't quite see for the amount of light glare and stuff here, but then you just need to just push it down like that. That's it. That's on. Of course, it's one of those cases where you really need to lift it up and inspect this front edge to make sure those clips are all in. They're in. That's it. I mean, it's really nice, isn't it? A really nice machine. I was going to sell this. I'm tempted, certainly for the moment, to keep it for testing. But I think it's a really, really nice machine. And I didn't do too bad on this. I picked this up, I'm trying to think what year it was, 2017 I think, something like that. Or it might have been 2018, and I think it was 50 quid, which I think was alright. They were selling around that time for £100 each, Pentium 3s. These days, I don't know. What do you think something like that's worth these days? There's still the odd black mark. I'll get a bit more baking soda onto some of these marks here. But, and it's a bit dirty there. I can see dusty fingerprints where I've just touched it actually. But I think you'll agree, it's not that bad. Yeah, you've got some fading where the labels and things were. But all of the sticky marks all around this have gone. I can show you that. If you look at the sides, if you look at that side, yeah, you can see it's pretty faultless. It's almost perfect, that. And I'll show you the other side. Be careful not to squash anything on the bench. Yeah, so some label marks. Still got the original warranty thing here with its asset number. A few smears that should come off with a bit of baking soda maybe. But it's yeah, it's pretty good. I'm very, very, very pleased with it. Yeah, and a quick look around the back. So let's have a look what we've got. We've got a serial port, parallel port, USB. That's rare. And the USB was coming in with the Pentium 2 and Pentium 3. I'm not sure what that is. We've got 2 serial ports here. We must have. Or a dedicated mouse port. But mind you, it's got PS2 keyboard and mouse. It's keyboard at the bottom, mouse up there. You've got a lock there. You can actually padlock that to stop someone going in it, I think. Because I think that's half of that's on the lid. And then built-in VGA. It's got an ATI, I want to say Rage or Radeon or something built in. I can't remember. But we're going to look at this in the video. We'll look at that then. And it's got an RJ45 LAN, 100 megabit probably, because gigabit wasn't out then. And then the built-in audio connectors here. I can't remember which one I had the speaker in there, but you know, like line-in speaker, microphone or headphones, microphone, etc. It's quite cool. And obviously we've got 3 spare slots there, and internally, I'm just thinking we've got 4 slots internally. Why have we only got 3 slots here? That's weird. Yeah, so we've got 3 slots here, but there are 4 slots internally. There are 2 PCI slots and 2 16-bit ISA slots. Maybe one of them can't have an output here. I don't know, you could put something in the bottom one. Unless the bottom one's AGP, but then that would make sense because there's nowhere to stick the video connector. So yeah, it's not got AGP this. But I think the video card that's on board might be AGP built in, if you see what I mean. I could be wrong, it could just be PCI. Anyway, I do hope you found that video interesting. Please join me in the next part. We'll do some upgrades and stuff to this and test out some of the bits of hardware I've got. Thanks for watching. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. I'll catch you in the next video.